You'll be sorry. Okay, so let's start with this funky thing. First is simplifying radicals. So simplifying radicals, you just look at the number that's under your radical and you need to break that down. So I could break 32 down to 1 times 32, to 2 times 16, 4 times 8, whatever. Now, do you guys remember why I'm picking 16 times 2 to break that down like that? Because 16 is a perfect square. I want to look, if I can, for perfect squares because it minimizes my work. 8 times 2? I mean 8 and 4, sorry. I'll show you in a second. So what do? I just take the square roots of both of these. The square root of 16 is 4. And then the square root of 2 is some crazy decimal. I'm just going to write it as the square root of 2. The square root is the opposite of that. Like 5 times 5 is 25. The square root of 25 is 5. So two numbers, the same number, I take it to the second power. It's like I'm going the opposite way. So if I got 36, what two numbers that are the same multiply to get that? 6. So the reason I was trying not to pick 8 and 4, Makai, is this. If I got 8 and 4, I got to break down 4 to 2 by 2. And then I got to break 8 down to 4 times 2. And then I got to break down 4 to 2 times 2. And then I look for pairs to pull out. There's one pair and there's one pair. So I can pull 2 times 2 out and be left with the 2. I still get the same answer. It's just, honestly, I think it's easier if you try to focus on perfect squares. Because perfect squares, you take the square root of it, boom, you're done. Otherwise I got to break it down like that. You still get 4 square root of 2, but, less work. So like this, for instance, 200 times, or 200, what two numbers give me 200? Say it again. You can say 25 and 8. Now 25 is a perfect square. Excellent. That's 5. But 8 is not. But 8 I can break down. 8 breaks down to 2 times the square root of 2. So then it ends up being 10 square root of 2. Does everybody follow me there? Or did I go too fast? Did I go too fast? Yes, no? Okay, well, just so I can hammer the point home. Okay, well, I'll try again. If I'm looking for two numbers that multiply to give me 200, I could have just said 102. 100 is a perfect square. 2 is not. Say it again, sir. Okay, do the same one. Got it. Well, because I asked y'all and somebody said 25 and 8. Yeah, 25 is a perfect square. 100 is a perfect square. Yeah, that's just the one she picked. It's not a big deal. Yeah, some folks asked for this. I'll go on both. So anyway, 25 perfect square. That's 5, right? But the square root of 8 is, that's 4 times 2. I can break 4 down to 2 times 2. Yep. So then I pick that 2 out because every pair gives me 1. So then that's how I got 5 times 2 times the square root of 2, which is 10 square root of 2. But I can minimize that by just saying 100 times 2, and the square root of 100 is 10. That's the difference. If I pick, I said a perfect square, and I probably should specify the biggest perfect square. That's less work on you. Now, it's not really that was that much work. It's just, you pick the biggest perfect square that goes in there. It's less work. Well, you don't have a lot of choices for 27. 9 and 3. 9 is a perfect square. 3 ain't. So that's 3 times the square root of 3. So now that I got all these, now I can say 4 square root of 2 plus 10 square root of 2 plus 3 square root of 3. Now, square roots, when you're adding or subtracting them, they act just like variables. So that's like saying 4x plus 10x plus 3y. Does everybody understand what I said, or do I need to write it down? Yep, because the 2's are the same and the square root of 3 is different. So it's like saying 4x plus 10x plus 3y. Because those square roots aren't exactly the same, I can't combine them all. Now these two are the same. So I can combine them and say that's 14 times the square root of 2. But here, I can't. That's just going to be that. And that's my problem simplified. I cannot go any further than that. Does anybody with a question on? Question on anybody, question on? It's Yep, no problem. Yep. So Joey, if I can get the biggest number that's a square root, I mean it's a perfect square, excuse me. And then I take the square root of 16 is 4. And then I got times the square root of 2 and then I'm done. That's the difference. hmm So I'll leave the second one for you. That's the one I did. Does anybody got any question on simplifying radicals? Okay, you got the next one. Yeah, the next is in that's for you to do. All right, let's look at dividing radicals. Well, I'm doing examples, and then you got one to work on, and then y'all can come back and ask me questions. You can try it. That was maybe I misunderstood what y'all were asking me. That's what I thought y'all were asking me to do. You know? Yeah, be my guest. But that's what I thought you were asking me to do, to give y'all examples for the study guide. So I'll do something, and then you got a problem to work on to see if you got it. All right. I want to divide something with radicals. Okay? Does anybody remember what I need to do? It's a word. I'm sorry, go ahead. Well, it's one word or it's a phrase. I'm sorry, you could say that too. Close. You need to multiply by the conjugate. If you got a radical like this, a statement where it's a whole number and a radical, I need to multiply by the conjugate. It's sort of like saying the opposite, but not exactly. The other word I was looking for is rationalize. Rationalize. Rationalize and conjugate. What's the conjugate of 5 minus 2 times the square root of 3? Go ahead. Nope. Makai, say what you're saying. So all I'm doing is changing this sign. So that's 5 plus 2 times the square root of 3. And I can do that. I have to do that top and bottom. Yeah, blah, blah, blah. So I'm going to multiply that top and bottom. Now, why am I multiplying the top and bottom? Because when you have a fraction and you multiply the same thing on top and bottom, it doesn't change your value of the fraction. It may make your numbers bigger or smaller. Say it again, sir. Because that's what I just said, Joey. If you have a fraction, like for instance, 1 over 2, right? We know that's 1/2. If I multiply 1 over 2 times 3 on top and bottom, I get 3 over 6. Isn't that 1/2? 3 is half of 6. So as long as if I got a fraction and I multiply the top and the bottom by the same number, it doesn't change the value that fraction represents. It may make the numbers bigger, or maybe you multiply it and makes the number smaller, but it's not going to change the value as long as you're consistent with what you're multiplying. I just threw that up there to prove my point. So half got nothing to do with this problem. I just was saying, for example, 1/2 is a fraction. If I take 3 top and bottom and multiply, I still got something that represents a half. Somebody's phone is on the floor, I think. Okay. It just looks like his body is stepped on. That's why I said it. Okay, anyway, let's go back with this. So I'm going to multiply by the conjugate. Do you remember why I multiply by the conjugate? I need to get rid of the radical in the denominator. Okay? I need to get rid of the radical in the denominator. So how do I do that? Well, if I multiply by the conjugate, the radical goes away. You could also think about this like the difference of squares. If I multiply by the conjugate, all I got to do is multiply the two first numbers and then the two last numbers. So I multiply 5 times 5, and I multiply 2 square root of 3 times 2 square root of 3. So 5 times 5 is easy, right? 5 times 5 is easy. That's 25. Minus, now I need to talk about what 2 times the square root of 3 times 2 square root of 3 is. That's 4 square root of 9, yes, which means what? So then, which means what? You're right, Nashila. Let me just show you what you're talking about. So I said 2 times the square root of 3 times 2 times the square root of 3. The lady said 4 square root of 9, which is right. The thing is, what's the square root of 9? 3. So then that's 4 times 3. What's 4 times 3? 12. So that's what that is. Yep, because that's the thing, Nashila, is 4 next to the square root of 3. We treat it just like a variable. What's 4x? That's 4 times x. So what's 4 square root of 3 is, or excuse me, 4 square root of 9, that's 4 times the square root of 9. So that's 12. Now see, but that's the whole point of multiplying the conjugate. Because look at the denominator now. It's 25 minus 12. It's no longer got a square root. That's the whole point of multiplying the conjugate. Now, you can have a square root on top. So that's what I'm going to do next. I got the square root of 3 times 5. That's 5 times the square root of 3. And then I got the square root of 3 times 2 square root of 3. That is 2 times the square root of 9. Okay. I am multiplying the square root of 3 times 5. 5 is a whole number. The square root of 3 is a square root. They don't interact. So it's just like I was saying 5 times x. So it's just going to be 5 times the square root of 3. Now I'm going to multiply the square root of 3 times 2 times the square root of 3. Remember what I said about square roots? Square roots, they're inside, right? Whole numbers are on the outside. So if I multiply two square roots together, right, then they can interact. Square root of 3 times the square root of 3 is a square root of 9. You follow what I'm saying, ma'am? But see, 2 times the square root of 3 is just 2 times the square root of 3. Because one's outside, one's inside, they can't interact. You got what I'm saying? So then what happens here is the square root of 3 times 2 times the square root of 3. That 2 don't get touched. But the square root of 3's do, I get the square root of 9. But see, I can simplify that further. So the top, I get 5 square root of 3. And then I got, what's 2 times the square root of 9? 2 times the square root of 9, what's that? 6. Yep, 9 is a 3, and 3 times 2 is 6. So that's 6. You didn't get it, Joe? Okay. Yeah, see, let me make sure you got it. 2 times the square root of 3, right? They can't interact. One's inside, one's outside. You got me? So I treat it just like a variable. 2 times x. You know, x times 2. I don't know what x is, so I can't go any further, right? So then if I got 2 square root of 9, that's 2 times the square root of 9. The thing is, square root of 9, I can simplify. That's 2 times the square root of 9, which is 2 times 3. You know, because the square root of 9 is 3. These are supposed to be multiplied, but because one's under the square root, it's inside, the other one is out here. So they can't interact.
You okay, just keep the 2 in there.
Yep. Keep the 2, multiply the 3.
Okay, it was just the way you were saying it.
No, you go, Joey. That's why we asked. Yes, sir.
You're not recording.
Yes, I am. Why not? No, I'm just not streaming it.
Charlie, you're streaming. You have a live camera on our class.
Yeah, see, I'm recording it. I'm just not streaming it. So anyway, 25 minus 12, 13. That's my final answer. No, 13 on the bottom is final answer. Yeah, that's the whole thing. Does anybody got any questions on that? Dividing. Yeah. The next one is for you. That's what I thought y'all wanted. I thought y'all wanted a study guide to where I give you an example and then y'all have one to do. So I'm saying the next one's for you. Yeah. I listen. I try. You know, plausibly. Um. Okay. I'll yeah. Well, the thing is this though. Q. Like I was telling Joey. 2 times the square root of 9. Remember, 9 is under the square root, so that's inside. 2 is on the outside. They can't interact. It's 2 times that. But see, we can simplify the square root of 9. We know the square root of 9 is what? 3. So then it's 2 times 3. That's where we got 6. Yes, sir. All right. So I'll leave that one for a second, and then I'll blase de blee. Okay. Next, we got to divide polynomials. I couldn't hear you, ma'am. Yes, ma'am. Yes, ma'am. Well, that's the thing. I kind of wanted to. I wanted to give you say a day, so we could work on that tomorrow if you like. Yeah, I don't think I'm gonna have enough time this hour, but I was trying to get through as many examples as I could. It's okay. Everybody blase to bleed. Okay, so the next one, I've got 2x cubed minus 13x squared minus x plus 3 divided by 2x plus 1. Now, there's a box method and there's the long division method. Now, I'm going to go with long division because I think it's a little easier to follow. But if you want me to do the box method, I'll do that too. So long division is just, you write it like a long division problem. Okay, I would not like to record you saying murder, murder, murder. So could you not do that, please? I'd rather record you sitting down and not saying anything. But yeah, that's what I'd rather. Anyway, so what do I got? I appreciate it. So I've got 2x plus 1 that I'm trying to divide into this other polynomial. So all I'm doing, I'm sorry, go ahead, sir. I didn't hear you. Okay. Oh, you got it? Well, then hit me. What do I do first? Okay. Because my man says, how do I get 2x to the third? Yep. I look at what I'm starting with, which is 2x, and I think about what else do I need to multiply to get 2x to the third? And just like my man said, x squared. X squared times 2x is 2x to the third. But I got to continue with what else I had. So I got to say x squared times 1. So that's plus 1. Well, I'm gonna write 1x squared, but in mathematics we're lazy. We don't write the ones. But just for the sake of argument, I'm gonna write it. Now, here's a step that you can't forget. You cannot forget that you're subtracting this. So you go through and change both the signs. So when I subtract, I got 2x to the third minus 2x to the third. They cancel each other out. Say it again, sir. Yes, sir. Yep. And so here I got negative 13x squared minus 1. Like I said, if you get your signs mixed up, it's going to be a heck of a problem. So negative 13x squared minus 1. What's that going to be? It's going to be negative 14x squared. That's what I was saying about the signs, Joey. You got to watch it because you can mess yourself up. So now I bring down the next thing, which is negative x. And now I need to match 2x to negative 14x squared. So what do I got? What's the next thing? I've got 2x. I need to match that to negative 14x squared. What do I need to multiply by? Close. Say it again, ma'am. That's close. There's one more thing I need. Negative 7x. Negative 7x times 2x is negative 14x squared. And then I also have to multiply the second one, so that's minus 7x. Is everybody with me there? Yes, no? Okay, so now I got to subtract. So I'm subtract that, and when I subtract that, I'm changing my signs. So that's negative 14x squared plus 14x squared. So those two things cancel each other out. Oh shoot, I didn't want it. Well, oh well. And then what do I got left over here? I've got negative x and positive 7x. Remember, I got to change the sign. So negative x and positive 7x. What does that leave me with? Yep, I got to change that sign. It was negative, now it's positive. So negative x and positive 7x. What does that leave me with? 6x. Yeah, that's negative x, Joey, and then positive 7. So like negative 1 and positive 7, so that's positive 6. So I got 6x, and then I bring the 3 down. So now I've got 2x, and I got to get the 6x. What do I need to multiply by? Plus 3. So plus 3, that's 6x plus 3. I subtract, and I get 0, no remainder. So that's my answer right there. Anybody with a question on? Question on anybody? Question on? Okay. Let's see. You flip it for real. We got now we just got multiplying polynomials. So I've got did I need to do the box method? Yes. That was dividing polynomials. Now, I would suggest the box method for this, although you don't have to. But again, you can just multiply it straight out, or you can use the box method. Now, I think the box method works better for multiplying. I draw because there's 3 terms. This is a trinomial times a binomial. So I need a 3 by 2 box. A 3 by 2. The 3 is on top, so I write those terms up top. And then the 2 is on the side, so I write those on the side. And then I just multiply every box. Every box, I multiply what's on top and what's on the side. So, yep, pretty much. X squared times x, that's x to the third. Negative 4x times x is negative 4x to the second. And then 4 times x is 4x. So anybody got any questions on that first row? Okay. Say it again. No, I said I'm more comfortable with the box. I didn't say you got to. So next, I got x squared times 3, so that's 3x squared. And then I've got negative 4x times 3, that's negative 12x. And then I've got 4 times 3, that's 12. So what's going to happen next is I need to combine my like terms and write them all out. Pretty much. So the other way to do this is to just multiply the stuff straight out. So we got this, right? I multiply x times everything. So x times x squared is x cubed. X times a negative 4x is negative 4x squared. And x times 4 is 4. Then next, I multiply 3 times everything. 3 times x squared is 3x squared. 3 times a negative 4x. Oh, shoot. I forgot the x. And then 3 times a negative 4x is negative 12x. And then 3 times 4 is 12. And then I can just combine these things. I got x cubed. I've got minus x squared. I've got minus 8x. And then I got 12. And that's my answer. Or I could use the box and write everything down. X to the third minus 4x squared plus 3x squared plus 4x minus 12x plus 12. And then I combine like terms. So either way, you still get the same answer. X cubed minus x squared minus 8x plus 12. So box method or just foiling or multiplying it out. I will say that I think the box method for division is a bit trickier. But for multiplication, I think it's just on time. Does anybody got any questions? Multiplying polynomials. You said don't change it? Okay, can I do that? Okay, I'll just do that. So I'll start right number 5. That's find the first and last term or terms. Actually, okay. I need you to not talk about that nice lady on my recording, please. Yes. Okay. So I got these 3 binomials that I'm multiplying. Okay. The first term is going to be all of the x's multiplied out. The last term is going to be all the numbers multiplied out. So that's all you do. X times 2x times x. That is going to be 2x to the third. Whoa, not fourth, third. Yeah, I know, my fault. And then the last term is going to be negative 3 times a positive 3 times a negative 1. That's going to be positive 9. Now, I want you to understand this is not what I'm looking for. All right. I want something like this is the first term, and then this is the last term. Now, on other folks, when folks did the test before, I let it go if you just put the first plus the last or first minus the last. But that's not what I'm looking for. I'm asking for the first term and the last term. They should be 2 separate things. First and last terms. It's number 5 on the review. So all I did was take all the terms with the variables, multiply them, and then all the terms with the numbers and multiply them. That's it. You understand what I'm saying, Prince, or no? That is a 3. Yeah, I said 4, or I started to say 4, and I'm like, wait a minute, it's only 3. So I backed up. X times 2x times x. There's 3 x's there, so x to the third. There's only 2, and then no numbers, so that's 2x to the third. Negative 3 times positive 3 times a negative 1. The negatives cancel each other out. 3 times 3 is 9. That's it. Positive 9. All I did was multiply the numbers, get some, multiply the variables. Negative times a negative. That's negative 3. That's negative 1. The 1 didn't change anything, but the negative canceled the other negative out. That's why it was positive. All right. Does anybody got any questions on that? Okay. Let's do number 6. Number 6 was confusing to a lot of people. Okay, I need to write that again because that's too big. Okay, so let's talk about this. This problem, we want to simplify and write in standard form. You guys know what standard form is? Yep. Well, I mean, it basically breaks down to whatever the highest exponent for your variable is, that's to be your first term. And you go down, you know, you go down by 1 until you get to the number. So, I'm sorry, go ahead. Yep. Plus CX plus D. The thing is, see, I want you to understand that because if you look at this, the things are out of order. They're not in standard form now. So it's okay that they're not in standard form. You can actually do the problem and then rearrange it afterwards. So first thing you need to do, but before I say that, a lot of you saw this problem and thought it was a multiplication problem. It is not. It is a subtraction problem. Yep, a lot of people drew box methods and multiplied this stuff together. Way too much work. This is this polynomial minus this polynomial. That's the subtraction problem. The thing is, though, when you're subtracting, you only subtract the stuff that's alike. So when you're doing something like that, what I would suggest doing is you first distribute the negative throughout all your terms. So I'm going to have 2x squared minus x cubed minus 9x plus 1, and then I'm going to distribute the negative. So minus x cubed minus 7x plus 3x squared minus 1. Does everybody follow what I did? Did everybody follow what I did? All right, so next. Now I'm just going to, you don't have to do this step, but I'm going to do it. I'm going to write everything that's alike. I'm going to write it next to each other. So I got negative x cubed and minus x cubed. And then I've got plus 2x squared plus 3x squared. Then I got minus 9x minus 7x plus 1 and minus 1. I rearranged the problem so only no problem. Okay. So anyway, Prince. So what's going on with this is I rearranged the problem and put everything. Well, not so much negative. I just rearranged the problem, put everything that was alike next to each other. So right here, I got -3, or excuse me, negative x to the third and negative x to the third. So I'll put them there. And then I've got 2x squared and 3x squared. Put them right there. Then I've got negative 9x and negative 7x. Put them right there. Positive 1, negative 1. Put them right there. So now all alike terms are like right next to each other, as opposed to like everything being like that. Did I lose you? Does it make sense or no? Okay. The first thing I did though was I distributed the negative because I'm subtracting everything that's in here. So because I'm subtracting it, I gotta put that negative on everything that's in there. So that's the first thing I did was minus that, minus that. Oh, because it's already minus, plus that, and then minus that. That's the first thing I did. Then I rearranged it all so everything that was alike was next to each other. And now I'm going to combine the like terms. So I've got a negative x to the third power and a negative x to the third power. That becomes 2. 2 x to the third power. I've got 2x squared and 3x squared. That's plus 5x squared. I've got negative 9x and negative 7x. That is negative 16x. And then finally, I got positive 1 and negative 1. They cancel each other out. So this is my final answer. That's my final answer. Does anybody have any questions? Okay. That's number 6. Simplify and put in standard form. The reason that when I rearranged it, I put the highest exponent first because that puts things in standard form for me. Because if I would have did it like this, I would have had to rearrange it afterwards. So I just thought I'd rearrange it now. Anybody got any question? Question? Couldn't hear you, ma'am. Is there a P3? Yes. Okay. Let's see. Do I got enough time? I got a couple minutes. 7. Completing the square is gonna take a second. So I've got like what? I don't understand. I mean, it all looks like it's gonna take his on, but okay. Let's find the zeros. So find the zeros with multiplicity. Okay, so f of x equals x minus 2 squared times x squared minus 4 times x minus 1 to the third power. Okay, so here's what I got. No problem. Okay, so here's what I got. I've got, I'm looking for zeros. Yes, that's number 8. I was going to do 7 and somebody asked me to do 8 instead, so I'm doing 8. Why? Does it matter? Doesn't matter. Let's not take any more time up. Okay. Right. That's why I want to get this done. So anyway, so I'm looking for zeros. So I take each one of these binomials and I set them equal to 0. The thing is, sort of, but the thing is, it could be easier on me if I factor this. Now, why do I factor it? Let me explain. X squared minus 4, that's the difference of squares. Because I can take the square root of x to the second power and the square root of 4. That factors the x minus 2 times x plus 2. Does everybody follow what I'm saying? I can factor that. So now if I rewrite this thing, it's going to be x minus 2 to the third power times x plus 2 times x minus 1 to the third power. Because there's x minus 2 to the second power, and then there's another x minus 2. So because they're being multiplied, I can just say that's x minus 2 to the third power. Now there's a reason why I did that. Because I'm finding the zeros with multiplicity. Now that I know that that's to the third power, I know that x can be positive 2 with a multiplicity of 3. I'm surprised you haven't heard me squeaking the way I get up. You see it? Okay. Yeah. Yep. It's 3 of them total. And that's gonna get to the cut to the chase of our multiplicity. Nope. Okay. The original problem says x minus 2 to the second power. When I factor this, it factors to this, which is x to the x minus 2 to the second power times x minus 2. When I think about that, that's really x minus 2 to the third power. And there's a reason why I did that, because it makes my multiplicity easier to see. Remember what multiplicity is. How many times is that thing going to give me 0? If I plug 2 in here for x, it gives me 0 twice right here, and another time it gives me 0. It gives me 0 a total of 3 times, which happens when I put 3 right there. That's what that multiplicity does. No, believe me, Q, if I was angry, you know. Plus, I'm old. Sometimes I just look grumpy. So anyway, the next one I got x plus 2. Yes, ma'am. So x can equal negative 2 with a multiplicity of what? Just 1, because it's only there once. with a multiplicity of 1. Say it again, ma'am. Yeah, that's what I did. Well, see, that's the thing. The Shala, the 0 that I'm looking for is the opposite of what you see. X plus 2, X has to be a negative 2 to get 0. Yep. So then the last one, X minus 1 to the third power, that's a positive 1. And write that with the multiplicity of 3, and we'll call it a day. All right, and let's stop this.